Chemistry time.
Welcome back to Chemistry Time. For today's discussion, we will begin talking about the classification of matter. Matter can exist as a solid, liquid, or gas, where a solid has a defined shape and volume because particles have little free motion and are held in an orderly manner. Liquids have a defined volume but assume the shape of its container because particles in the liquid state are not held together in a rigid fashion, but are still close together and they can move freely around each other. Gases assume both volume and shape of its container because they do not have defined volumes or shapes because gas particles are separated by large distances and can move freely around the container in which it's in. We can further define matter as being a pure substance or as a mixture, where a substance simply refers to the chemical composition of matter and defining properties of it. Some examples of pure substances are salt, sugar, iron, water, and many more. Where a mixture of substances is a result of more than one substance, such as salt water, because this is now a mixture of two substances. Substances exist as a solid, liquid, or a gas and can be converted from one state to another without changing the chemical composition of the substance, which this is known as a physical change. An example of a physical change is when ice water in the solid state is heated and it will melt to form water in the liquid state because we are not changing the identity of matter. If we continue to heat this, it will then change states again from liquid to a gas. When describing a substance based on physical properties, this includes color, state of matter, boiling point, melting point, freezing point, etc. Mixtures can be further classified into two categories, homogeneous and heterogeneous mixtures, where homogeneous means that the composition of the mixture is uniform and has the same composition throughout, whereas a heterogeneous mixture is not uniform and does not have the same composition throughout. An example of homogeneous mixture is salt water because we cannot distinguish the difference between each of the two substances from one another. An example of a heterogeneous mixture is like Lucky Charms because you can physically see the different substances and it does not have the same composition throughout because you have varying ratios between the whole grain cereal to marshmallows. Mixtures can be separated by physical properties, which simply means we are not changing the identity or chemical composition of the substance. Examples of physical processes include filtration, which separates based on size. We can separate substances based on the boiling points using something known as distillation. When identifying or describing a substance, you can use either a quantitative property, which is a measurable amount, or a qualitative approach, which is describing the quality of matter without using numbers. An example of quantitative measurement is mass of the substance, where if you wanted to describe the color or shape of it, these are qualitative properties. Up until this point, we have only discussed physical properties and change where we do not change the identity of the substance, only the state of matter. However, this is not always the case, and we can have the instances where the identity of the substance is changed, which is known as a chemical change. Once a substance has undergone a chemical change, the original composition no longer exists. An example of this is if you leave an iron nail outside for a number of days, and when you come back later, you see the nail has rusted. Well, the iron has undergone a chemical change because it's no longer just iron. It is now an iron oxide, meaning it has reacted with oxygen. A major difference between chemical and physical processes is you cannot separate or recover substances that have undergone a chemical change because they have reacted and formed a new, different substance. Just like with physical changes, we can use chemical properties to describe the chemical change a substance can undergo. These can include flammability, reactivity, radioactivity, and even the smell of a substance. Keep in mind that these properties will change as a substance undergoes a chemical change. As we continue to discuss chemical and physical changes, it is important to note the driving force behind these changes is energy. The two main types of energy we will be dealing with are kinetic energy and potential energy. Kinetic energy is the energy of motion and is given by the following equation. Kinetic energy is equal to 1/2 mass times velocity squared. As we will see in our later discussions, temperature is actually related to the average kinetic energy of the molecules in a substance. The other type of energy that we will be focusing on is potential energy, which is the energy that is stored in an object and is available to perform work. This can take the form of physical potential energy, which is related to the position, or chemical potential energy, which is the energy stored in the chemical bonds of a molecule. In order for chemical or physical changes to occur, energy must be transferred or change forms. It is important to note that energy is never created nor destroyed. It is merely transferred or changes form. This is known as the law of conservation energy. I know we covered a lot in today's discussion, so let's quickly review. We discussed the different phases of classifications of matter, such as pure substances and mixtures. We also talked about the different types of mixtures you may encounter. Finally, we discussed chemical and physical properties and what it means for an object to undergo a chemical or physical change, as well as some of the driving forces behind them. I hope you enjoyed today's discussion, and we'll see you in the next episode of Chemist Tea Time. Thank you.